Welcome to 11.8 Notes, the final section of the chapter. For your enjoyment and challenge today, we're going to have a new vocab word called the semi-perimeter. The semi-perimeter is exactly what you think it probably is, half of the perimeter. So to find it, you're going to find the perimeter of your shape and then just divide it by 2. So the semi-perimeter, noted S for our variable, would be the addition of the sides divided by 2. And using some not so high level math calculation skills, you can work your way through and find out what the semi-perimeter is. It works the same on a 3-sided object, same as a 4-sided object. We're going to add our 4 sides together. We're going to divide by 2. We'll end up getting 15 for this one. That's finding the semi-perimeter. Where does this come in useful? There were 2 ancient mathematicians who kind of found some theorems based off of the semi-perimeter. So we'll go through those 2 to finish our chapter on area. First one is ancient Egyptian mathematician Heron of Alexandria developed a formula to find the area of a triangle when you are just given the side lengths. His formula, which is theorem 111 in our textbook, is the square root of the semi-perimeter multiplied by the semi-perimeter minus one of the sides, semi-perimeter minus the B side, and semi-perimeter minus the C side. It's kind of irrelevant which side you call which. They kind of define our variables below. S, semi-perimeter, and A, B, and C are 3 sides of a triangle. This has been known as Hero's formula. Notice it only works on a triangle, and you have to be given the 3 sides or some other information to get that for this to work. So I made a very simple triangle, a classic 3, 4, 5. Obviously here, you could just find the area by doing 1/2 base height. 1/2 4 by 3, it's obviously going to be 6. However, we'll use Hero's formula to check on that. So the semi-perimeter, which will be the sides, perimeter divided by 2 is 6. And now to use the formula, I will do the square root of the semi-perimeter multiplied by semi-perimeter minus one of the sides, semi-perimeter minus the second side, semi-perimeter minus the third side. And that gives us this setup, 6 times 3 times 2 times 1, all in a square root. 6 times 3 times 2 times 1 is 36. So I have the square root of 36, which is 6. So sure enough, it worked. It gave us an area of 6, even on a very simple triangle. If you ever have the simple triangle, you will probably choose to use the 1/2 base height formula. But what if you didn't exactly know how the triangle was set up, and what if you don't have the right angle and the height given to you? So if you draw a triangle with sides 5, 6, and 9, you're going to have to do some trigonometry to find the height of this one. Or you can use Hero's formula, where first you will find the semi-perimeter of this triangle will be 10. And then we follow their formula. 10 multiplied by semi-perimeter minus each of the 3 sides, which will get us to 10 times 5 times 4 times 1, which gets us to square root of 200, which gives us an area of 10 root 2 units squared. That's the use of Hero's formula here. And that takes care of any triangle. And then on the back side, as you flip your page, we will have a separate formula. Ancient Hindu mathematician Brahmagupta developed a formula to find the area of an inscribed quadrilateral. So anytime that the shape is inscribed in the circle, quadrilateral, this formula can be used. It's also known as a cyclic quadrilateral, and it's anything that's inscribed. Kind of makes sense. It sounds like circle, which also sounds like pi r squared. Sounds like area to me. But that's a side note. His formula, which is theorem 112 in our textbook, is the square root of, and sure enough, it's the semi-perimeter minus each of the sides. Notice the difference from the previous formula. You don't have the initial multiplication by the semi-perimeter in front. So notice you're missing that there, but if you go back to Hero's formula, you have it there. So when you're kind of memorizing our formulas, you just need to know that that's that. So here we go. We have a quadrilateral that's inscribed in a circle. First, we want to find its semi-perimeter. This one happens to be a decimal. And then we follow our formula. And notice it tells us to round it to the nearest hundredths place. As we work our way through, we'll get the square root of a rather large number. And when we use our calculator, we'll get our answer. 31.95 units squared will be the nearest hundredth spot. There are a couple examples coming up next. Something you could do is pause this video and then restart it after you try them, so you get to use both formulas. But we're going to show you the final four right now. We got to make sure we use the correct formula. Notice the first one, we have a triangle, so that would be using Hero's formula. Find our semi-perimeter, use our formula correctly, multiply correctly, and then simplify our square root if we have one. So 2 root 6 units squared, inches squared. The second one, we have another triangle, so we're using Hero's formula. Find the semi-perimeter, insert into our formula, calculate, multiply, get a simplified square root. On number 3, we have a quadrilateral, so we are going to be using Brahmagupta's formula. Semi-perimeter, we establish as 12. Properly put into our formula, get to our multiplication, simplify our radical, and that is it with that one. Number 4, the final question, we are looking for the area of a triangle. We're going to be using Hero's formula. If you started to do this one, you might realize that as you work your way through, you actually get a square root that's a negative. But then if you look more carefully, or if you realize from the beginning, this is actually a trick question from the beginning. This triangle does not exist because of the triangle inequality theorem from chapter 1. The two sides, 4 and 6, are not larger than the third side. So this triangle could not even be created to start with. So no solution, not a triangle, etc. Classic trick question to end it. Hope you have a good one. See you later.